Okay guys, so what I'm going to go through today is your mandatory prac. Now, in normal circumstances, you'll be doing this practical in class, you'll be conducting it yourself, and then your assessment would be to modify it. But obviously things are a little bit different at the moment with COVID and everything going on. So basically what I want to go through today is a quick video demonstrating how we would do the mandatory prac. You will have the sheet there that has all the instructions, it has discussion questions for you to answer, and I'm providing you with dummy data. So you'll still be able to participate in it in that way. You just aren't able to conduct the prac yourself. You can actually do somewhat similar pracs at home, but we can talk about that another time. What we're then going to do is, based off this, I'm going to send you out some information describing some alternate pracs you could have done, some modifications you could have made, as if you were making the modifications yourself for the student experiment assessment, and we're going to work through that as a formative task in class, okay? But I will get to that another time. All right, so we've got our gear here today, and if you have a look at the sheet, you'll see what gear we need. We've first got the gas syringe, so maybe if you come around, we'll have a look at our equipment. So we've got our gas syringe. Now, gas syringes, funnily enough, are a syringe that are used for collecting gas. In our experiment, the products of the chemical reaction are gases. So what's going to happen is we're going to have our 250 ml conical flask with a bung in the top here. Okay, so the bung has got a hose attached to the flask, and as it produces gas, it's effectively going to push this out, and that's going to give us a measure of how much gas is being produced. We've got some other equipment here. We've got the ever important distilled water. Okay, we use this for making up solutions and rinsing. We've got a thermometer, which I've already used to test the temperature of our solution, so you're not going to see me using that today. We've got here a piece of equipment that I'll make sure that you are familiar with when we get back, and this is an automatic pipette. Okay, it's used for taking very small volumes. This one's 100 microliters to 1,000 microliters. 1,000 microliters being 1 mil. Okay, so we're going to use this today to take our samples of Catalase solution. We've then got a 5 mil glass pipette here, and it says on the side, I'll see if we can get this in shot, it says 5 mil in 1 in 10 at 20 degrees. So what that means is at 20 degrees room temperature, the amount of error that this has is 1 in 10, okay, or 10%. So if it's 5 mils, then the 10% error we're looking at is going to be 0.05, I think. Sort out maths later. But then we've got our pipette filler here, okay? This thing we carefully put on the top like that, making sure you don't break it. All right, we squeeze in the top, and then whenever we want to suck something up, we just use this little lever to suck or push back out. Okay, so we're going to use that in just a minute. Lastly, we have our solutions. Okay, we have 3% hydrogen peroxide we're using today. One of the potential modifications that could have been made for this experiment is using a variety of concentrations of hydrogen peroxide. Last year we had 1%, 3%, 6%. We did also have some that were in between. And we've got here a 1% solution of Catalase. Okay, so I've taken 1 mil of our enzyme solution and added it to our 100 mil volumetric flask. Okay, we fill it up to the line. It's very, very accurate in making up solutions of a set concentration. Now, this is an incubator here, not an incubator, sorry, a water bath, and it's used for setting or getting solutions to a set temperature. So at the moment, we've got it set to 40 degrees. Okay, so we want it at 40 degrees. It's a little warmer than that because I filled it up with hot water, but that's okay because it has acclimated our solutions to 40 degrees, which is what we want. Okay, now we've got all our equipment set up. Now it's just a matter of conducting the experiment. Okay, so the first thing we want to do is get some of our 3% hydrogen peroxide, which I've got here. Okay, and we're going to get 5 mil, a 5 mil aliquot. Aliquot just means a sample. Okay, so if we have a look at our pipette here, it starts off at 0, and then 1, 2, 3, 4, and 5's right at the bottom. Okay, so if I wanted to fill this up with 1 mil, I would go to 4. If I wanted to fill it up with 2, I would go to 3. Now, because I want 5 mil, I'm going to go all the way up to the 0. Okay? So, I'm just going to suck it up using the little lever here. Okay, make sure it's well in there. We don't want to suck up any air. Careful to get it to the 0, and this is being a little dodgy, but that's okay. Okay, so we fill it up, and then we put it into the conical flask and push down. Touch it against the side to get that last little drip out. And now we've got 5 mils of our hydrogen peroxide here. Now today I'm taking a little bit of time because I'm obviously explaining it to you. Hydrogen peroxide though is very, very sensitive to the outside environment. So it can actually start degrading and breaking down immediately. So in a normal experiment, if we wanted to reduce the error and make it as accurate as possible, we'd be taking this straight from the stock bottle into a smaller beaker and then taking a sample immediately so that we minimize that risk. All right, then we are going to put that off to the side. Okay, we're going to pop our bung in the top here. Press it down nice and tight. We don't want any gases to escape. And you'll notice that we've actually got 2 holes here. So one has our hose in it at the moment. The other one we're going to use for inserting our Catalase so that we can basically minimize the amount of gas that's lost. Okay, so make sure we put the lid back on that. Good lab behavior. Okay, I took a little sample of our Catalase before I put it into the water bath there. Okay, and I have actually checked the temperature of this and the hydrogen peroxide. The lab temperature at the moment is 25 degrees, and these have gotten up to 25 degrees. So I've acclimated them. All right, now this is set to 1,000 microliters, which is 1 liter. So I'm just going to push that down until I feel the first stop. I'm going to put it into my solution and slowly release it up to the top. And that's going to put 1 mil of our solution in there. Okay, then what I'm going to do is when I want to get rid of it, you just push all the way down to the second stop and release. Okay, that's how we get rid of it. Now, what I'm going to do, and this is going to happen quite quickly, is I'm going to take a sample with this. I'm going to squeeze it out into the flask, close the lid, and we're going to run it for 30 seconds and see how much oxygen or gas we make. So I'm just going to get a timer ready on my phone, okay? So we only want it for 30 seconds. And it's going to be a little bit of a mad dash because usually you would have help, okay? Alrighty, so you can come up nice and close for this one if you want, right on that sort of syringe and set up. Okay, so we've got this here. I'm going to squirt it in, and then we're going to start the timer straight away. Starting our timer. All right, now you can see some bubbles coming up there. That means we're producing gas. So the hydrogen peroxide is being broken up into oxygen gas. Okay, that's bubbling up, and it's pushing out our syringe. All right, we're 15 seconds, so we're about halfway there now. Okay, so you can see the syringe is getting pushed out nicely. All right, 5, 4, 3, 2, 1, and that is it. So the sample was at the mark just before 40. Okay, now each of these is actually 4 mils. So just before 40 means that it was at 36 mils. Okay, so 36 mils gives us, oh, actually, am I right there? 4, 8, 12, yep, 36, sorry, 36 mils. So we produced 36 mils in 30 seconds there with room temperature, 3% hydrogen peroxide, and a 1% Catalase solution. Now, in the actual experiment, we'd repeat this another 3 times so that we could get an average. All right, but we've done our room temperature sample. Now, all we're going to do is, you can see that's actually still bubbling. So it's still producing gas. We're going to empty that out. Okay, I'm going to give it a little rinse with some distilled water. So rinsing right around the edge. Empty it out. shake out a bit of water, and now we're ready to go again. Okay, so we're repeating the same process we did, but now we're going to take our samples out of the water bath. So we've got our 1% Catalase here in the volumetric flask, and my clever contraption to help keep the hydrogen peroxide down. I had a weight on the top, so this is our hydrogen peroxide. These are both at 40 degrees. Close that up to keep the heat in. All right, so repeating the process again, 5 mils with our pipette here. Really make sure you get any excess water out of there. Ideally, you'll have 3 flasks because the hydrogen peroxide will react a little bit with the water. Okay, so we're going to get 5 mils of our hydrogen peroxide. Into the flask, same as we did before. Keep in mind that you'd be well practiced at this. Okay, we touch it to the side there. Make sure we put the lid back on so that we're not spilling anything. Okay, and we've got our 1% Catalase here. So remember, it all happens pretty quick, and this is why having people in your group helps. You can have one person on the Catalase, one person putting the lid down, one person on the timer, etc. Okay, so it'll run a bit more smoothly for you guys. All right, I'm going to get our timer ready. Oh, first we need to push this back to 0. Okay, we need to put our lid on. Again, nice and tight. All right, get our timer ready for 30 seconds. And then we are going to suck up our Catalase solution. So push down. Suck it up. All right, and we are pretty much ready to go. There's 40 degrees. We would actually expect more to be produced due to a faster reaction rate. So increased temperature increases reaction rate. Okay, so we're going to stick that in. And here we go, we're off. Oh, I didn't start the timer. Oh no. All right, this one might be a little bit off. That's why having multiple people helps. But you can see that we are already at just over 30 and we're halfway through. So we're already eclipsing what we did previously. We got about 10 seconds left, roughly. Remember, we didn't do it that well. Okay, keeping everything the same as we did before for fairness. All right, and that is it. So we were at 44, 48, 52. All right, taking this off, and we dispose of that the same as we did, rinsing it again. Couple of things to keep in mind when we do this experiment, okay? And this is things you're going to have to consider when, if you are planning your own experiment, and also if you're writing it up, which you will be doing, okay? Think about why we did everything we did, okay? Why did we use a water bath? Why did we use high precision equipment? Why will we have done 3 replicates? All those sorts of things, okay? Think about the safety, putting lids on things, okay? Wearing lab coats, wearing safety glasses, all of that sort of thing. So these are the things you have to think about. Now, this video and the results are going to be coming to you soon, and you will be able to fill out the discussion questions, and from there we'll work on you designing your own experiment and modifying. Okay, thanks guys.